I'm so excited that you all came to a presentation with medication reconciliation in the title, because medication reconciliation is kind of like your junk drawer that you have in your home, that you know that the stuff in there is important and you want to clean it out, but you probably don't have a lot of time to do that, or as much time as you would hope or like. Maybe your organization of your files on your computer or something like that falls in the same category. Can I just get a read of the room really quick? How many do we have any clinicians in the room? Any pharmacists? No. And then technologists, raise your hand. All right. Sweet. Thank you. That's helpful for me. So I want to make sure and just kind of level set on the problem space and what we're talking about. So I want to start with what is medication reconciliation. It's the process whereby clinicians compare the medication list in the EHR to the list of medications that a patient should actually be taking, right? Their home medications, what's changed about their medication list while they've been in the hospital, et cetera. And to give you a little bit more of a practical example to this, I want to show you a real medication list that went home with the patient, okay? And you can see if you can spot, I highlighted two specifically errors on there, see if you can spot them. Lots of different types of errors. There's a duplicate medication here where, you know, a medication was not removed from the medication list, and then also non-formulary where a clinician was prescribing a medication, maybe couldn't find it in the formulary, and so they used the, you know, the non-formulary option and added the detail there. There's lots of impacts and results for the patient, and frequently these types of errors can result in major safety events or adverse events, adverse drug events, and result in readmissions, deaths, and various other causes. And so this is the problem space that I'm talking about today, and how we applied machine learning and now AI with the advent of language models and the benefits we're getting from that. So I have a question for you. How many of all discharges going out of a hospital, how many do you think have at least one error in them? Any guesses? 80%? 99%? 100%? 20? All right, we're across the board. You guys are, you know, right up there. Like, there's a lot of errors going on. Okay. This study across 2 pediatric hospitals found that it was 50%. I've seen other things as high as in the 60s or 70s. But it's essentially a coin flip if you have that error on your list, at least one error on your list. And there's a lot of impacts because of that. This other study showed that adverse drug events were the most common type of adverse event, so huge patient safety issue, right? And adverse drug events were among the most preventable. And so surely, if this is happening a whole lot, and a large portion of them are preventable, surely we're doing a lot to fix this problem. Yes, we are, but the standards for doing that and quality are pretty low today. This is kind of the current process, right? Across different service lines or specialties, you'll go through the process of medication reconciliation, and this is called checking the box, right? I did medication reconciliation, but it doesn't indicate whether or not that list was fully cleaned up and doesn't have any errors on it, right? And this will result in lots of errors going home with the hospital. The Joint Commission's current standard on this is that you do a good faith effort. And so the previous study that I cited that was comparing error rates across 2 pediatric hospitals, a large part of that was defining an error definition so that we could move beyond checking the box to actually using some sort of definition or standard for the quality of those medication lists going home. And so here's a couple of those examples: duplicate medications and kind of those consequences. Patient might take too much, they might overdose. Free text errors, missing details, missing route frequency, dose. Compliance, the patient said, I'm not taking this medication, but it didn't get taken off the list, as examples. And so in that study, and by defining those error definitions, the folks that I shared at the start, they were able to go through process of interventions to actually reduce the error rates. And some of the most common things that they did were going in and having education sessions. So they'd go and show a clinician, well, you used to prescribe this way, but the process has changed, and now we're using these prescribing practices, or changing the actual formulary or the rules and the checks within the EHR and changing the rule sets. Or maybe it's defining and clarifying roles, right? Yes, you are allowed to take this medication off this list even though you didn't prescribe it, et cetera, et cetera. So with this result, right, yes, we can reduce the errors that are going out and going home on patients' lists. What's the cost of doing that, right? And in this case, they were doing it manually, so it was a lot. And so my question is, do you have 3.5 pharmacists to spare? This is my friend Wendy, so if you're going to say, do you have 3.5 Wendy's to spare? And this is actually at a pediatric hospital that is much smaller scale. So at a lot of the institutions that you probably work at, the number is much higher than this. We worked with another one, a large institution that's actually, that question is, do you have 150 pharmacists to spare? So obviously doing this checking all those errors, it just doesn't scale. That's kind of where I came into the picture. How can we use technology to accelerate and scale the quality check of the medication list so that we can approach this problem and start to do better than just checking the box? So we set out an approach. This is kind of pre-AI models, or LLM models, I should say. And so we started with kind of taking a rules-based and leveraging machine learning, just traditional machine learning classification problems for detecting those errors. And we found that we could do a pretty good job of doing this at scale. And just to share some results, this is a comparison of 2 organizations, 2 different EHRs, both pediatric and adult, and the F1 scores that we got for both the rule-based approach as well as the machine learning models. And we're getting good high 90s or high 80s, high 90s in terms of F1 scores on those results and sending that data through. There were a few problems with this, though. When we had that large data set, in order to train those models, you needed a large data set, right? We were compiling 30,000 medications or something to do that initial training, and having clinicians go through and validate and create that ground truth on all this medication data, it just isn't, doesn't scale with a lot of the clinicians' time and how many demands they have on their time. And so that was one issue with this. And then also just the explainability of some of these models and bringing the clinicians along. We could use things like SHAP values and other things like that to show some of the weights, but not quite as effective as some of the newer methods and tools. So just to flash this up, I know we're in a technical session, so this is kind of the architecture that we deployed. This is AWS specific, but the process by which we did this is pretty generic. And the main goal here was scaling it and putting it into a pipeline so that they could do that on a regular basis and then produce those results. And we were doing it kind of retroactively and looking at that list retroactively with the plan to go into production and do that on a more real-time basis. And that'll bring us into phase 3, right? Where are we at now? So this is kind of a replacement of that traditional ML approach. So again, addressing those 2 problems of we have to create this huge data set to start producing results that the clinicians can look at and see how the model is doing. And then also from the explainability perspective, can we add more detail into how our model is making that prediction so that the clinician has better data when they're evaluating the response or reacting to an alert in real time and understand why the model flagged something the way it did. So the process by which we have done that is really diving into the problem and understanding how the clinicians are defining those errors today. And this varies across the organization. I've seen various different prescribing practices. It both varies because of the EHR, but also specific organizations have different prescribing practices for different things. For example, was it an organization where they were prescribing whenever they wanted to stop a medication, take it off the list, they'd actually just throw stop into the SIG and actually not remove the medication from the list. And so they had a whole different definition for how to do expired medications and things like that because of that. So I just want to show that as across different error types, some of these, like the compliance error, was pretty straightforward, and we can still apply a traditional kind of rule-based approach there. For free text errors, that's where we start to get into a lot of the kind of natural language and things that LLMs are actually really good at in interpreting the SIG and not having a super custom model to do that. And so that's been beneficial. And then the duplicate error was really where we saw the traditional machine learning approach be successful. And we've seen good things on the LLM side as well. For the LLM approach, I don't have, just to share kind of process and where we're at today, we have 2 organizations that are starting to look at this, both a pediatric and adult organization, and we're really evaluating the model performance. So we've had to start this LLM process by generating synthetic data and running it through that because of the access to the real world and kind of that data. But I hope to have results and kind of F1 scores on this very, very soon. Here's kind of our pipeline and architecture for that. So getting the data from the EHR, dropping that into a pipeline where we're able to query that data, store those prompts, get the LLM inference, and then parsing that output and putting that into a dashboard so the clinicians and whoever can see and plan their interventions around that data. Now, my last question here is really around how to implement AI evaluations. And this has been something that I've been very fascinated with recently. And I come from a product background, and so I'm very fascinated with how do we use all this cool technology and all the cool models we're building, but apply it in a real-world scenario and really get value out of those models. And AI evaluations, I know you all do, you're evaluating your models for success and how they are, but I found some of this information to be really practical and tactical in terms of applying that into those production scenarios. So we solved kind of the early problem of needing to have a large data set by being able to use the LLM to get those inferences right out of the gate. We don't have to curate that huge data set up front. But there's no replacement for going in, evaluating the data, seeing all those traces and how they're performing or how they're not performing. And so this is just one example of a medication going through the LLM and having that medication data there and evaluating this. This specific example is for a free text error. So it's evaluating this top medication for a free text error. We see in the SIG there's some detail about taking it with this other dose. And so our LLM prompt went through all the steps, which the clinician can see kind of all this logic that was applied, and then it flagged it for a free text error. And our human evaluators came through and said, actually, this isn't a free text error because of the other medication that is here on the list that is not a duplicate, but you're actually supposed to take these 2 together, right? And then with this data and going through and evaluating those traces, we're able to go through and look at the most common failure scenarios for our data and create a evaluation test suite so that as we apply changes to our model, changes to our prompts, which we all know that the prompts and the models and things change very frequently given the current rate of change, we can run all that through and evaluate all of our traces against those failure scenarios to ensure that our model's not tracking or getting off track as it's deployed in a production scenario, or even as you're testing and iterating on your prompts. I highly recommend checking out some content by Teresa Torres on this very practical examples of building some of these AI evaluation things into live products. So that is that. Any questions for me? I'd love to connect with any of you if you're talking about any AI evaluations or how you're applying these into real-world scenarios. That's my LinkedIn. Would be happy to connect with any of you and chat with you more. Thank you so much.